conditions, probably the amount of assigned resources for this program would be much less. That is why climate information is relevant and of utmost importance at the national level. The patterns of rainfall can help avoid forest fires. In 2011, the CONAFOR reported that 12,000 forest fires, and on the screen we can see the affected surface of these forested areas. But what should this climate information cover? From the previous presentation, we see that we need not only survival data or information. The person who raises the data, the observer, must have tools that must be reliable, well calibrated, and it must be pertinent. In Mexico, all the information or instrument used for the measurement of climate conditions are imported.
Otra de las características o necesidades que debe tener
of climate information
que tiene que ver con
has to do with not only as to where
estos datos
data should be
Además, debe
located.
tener bases de datos de calidad con sus metadatos correspondientes. Las observaciones, como
The
lo decía, deben ser
observations, as I was saying, must be continuous, both in time and
ya que
space,
todo el mundo sabe
since
que un
everybody
dato
knows that a
faltante
bit
es
of
un dato
lacking
perdido.
bit of data is something that is lost forever. So it is important to assess it on a constant basis, and it's part of the activities of the Institute. Aside from this, we must generate specific applications for the sector and of a general nature for the rest of the country. We have diverse needs from parcels with different characteristics for the productive sector, be it agricultural or for stock, and we need to know what are we to do in homogeneous sectors on a regional level in order to make decisions at a national level. I must communicate this information and not only make the tool, the database, the applications be good, but how are we to communicate this to those who make decisions that can be from the producer to a government agent. And this becomes what we know as climate services. And in these climate services, we are in a process of modernization. We will take the world framework dictated at the Third World Conference in Geneva. And this world framework for climate services is said to be important for each country, based not only on the institution at the national level, which is headed by the Meteorological Service, and there will be other agencies that can generate these services. And what are these services? Provide information announcing risks linked to climate. The raw material of the climate service is an important input of database, and we might have the value of average rainfall in a given country. Which organizations provide these climate services? In Mexico, the one that is supposed to provide them is the Meteorological National Service, and at the same time it should be the leader for other organizations. There are other climate services according to the needs of these institutions, like the National Electric Power Commission and the Center for the Atmosphere, the Navy, and several other agencies. How does this framework work for climate service? With the observations and the surveillance of climate conditions, should carry out research, modeling, forecast, which should be put in the information system with that interface with the users, which are varied. In Mexico, which are the needs and the agroclimate aspect? This information should empower the research work to assess the impact of distribution, variability, trends, and forecasts to help the agricultural production or the cattle production. For instance, a forecast of climate in the agricultural and cattle sector could be a measure to get adapted to climate conditions with tools that will aid the producer as to whether to plant, not to plant, or what type of seed, what type of tools he needs, etc. What are the information networks like in Mexico? The dots on the map is the sum of all the networks of climate stations, the ones of the Meteorological Service, the observatories, the automated stations, and we also have those of the National Power Commission, the Secretariat for the Navy. As you can see, there are places where there are many stations, a large concentration of climate stations, but there are large areas where we are not monitoring the climate. The areas in brown, orange-brown, is the areas of the use of land of the agricultural sector, forestry, and cattle. What is the network of the INIFAP? It has 939 automated stations, the largest network on a national level, covers 29 states of the Mexican Republic. Initially, it was implemented through a project of Zagarpa and from 2004 and 2007, but this has been increased. This is an example of an automated network. What is the distribution of this network? From the map, we only showed the INIFAP, and this is what we cover with the network. The network is based on agricultural conditions. Everything in orange is the use for agricultural purposes of the land. This network has a platform developed and managed by a national laboratory, which is in Aguascalientes. This laboratory carries out certain applications at the national level. We make certain warnings in regard to animal health and rainfall and what have you. And this is its function because it is in a national laboratory. You can consult the products of this network in this electronic page. And
what are the advantages and the disadvantages of an automatized weather stations? They are always satanized when they're conventional on their surface, the ones we know in Conagua. But the advantage of these conventional stations is that they've been there for a great many years. If we want assessments and forecasts, we need that information. These stations gather data every 24 hours. That could be an issue, and these observations are carried out manually. They need an operator that needs to be paid to go there every day and gather data at 8 a.m. every day. The synoptic surface stations, the observatories of the Meteorological Service take data and samples every 3 hours, report every 3 hours. That's why they're synoptic, but we only have 79 such stations in the country. Therefore, the coverage is quite scanty. The weather stations of INIFAP, the automatized stations, take samplings every 10 minutes and report their data in real time. Every 10 minutes, they forward the information. That is an edge over the conventional stations. The disadvantage of these automatized stations is that the maintenance costs are extremely high, and they need to be substantially increased because there are too few, and we would need many more across the country. How much does a network or an operating network cost? Okay, the cost of an automatized station varies according to the sensor and the manufacturing company. In Mexico, we do not have a firm that manufactures its own sensors. We have to purchase them abroad. We have no communication protocols for those sensors, not even for the reception and the storage of the information. In average, the INIFAP stations cost 200,000 pesos each, but they also depend on the amount amount of sensors and the characteristics of every sensor. And the preventive maintenance cost for a year of each one of these stations is 10% of the total cost of the station. So it's very costly to maintain such a network. The preventive maintenance consists in reviewing these stations, that grass doesn't grow around them, that they don't become nests for birds and insects. We have to clean the batteries. We need to change constantly the different parts of the equipment, and we have vandalism issues in some states. And these stations have to be agreed with the growers wherever they are found, and this is an important task for INIFAP. So what does the national network produce? We have many projects in regard to the management of water. One of them is a project of an early warning for drought and pests in Yucatan, together with other institutions, UNAM, our institute, and the vegetal sanitation institutions, to have a real-time warning on these pests and droughts. What are the expected products in terms of a drought? And we will produce indicators on the drought for a certain amount of years. We will create a cartography of space and time, of the space and time distribution and seasonality distribution. We will create a conceptual model of the drought and then have a real-time analysis. One of the tasks of the project required automatized stations, so we needed to study what is it we wanted to measure, how to measure it, which measurements required sensors, if that's the cost of a station, what's the cost of the project for the entire country. We established a network of 24 stations to complement the current and the existing network. We installed sensors with gauging characteristics and the parameters of the WMO, the institution that standardizes the weather conditions. And these are some of the samples of the stations. We need a structure to send and receive the data, the filter and gauge the information to be used. And some of the products, this is a weather map in Yucatan with the data of the conventional stations. This map was donated by Professor Enriqueta Garcia. You can see that Yucatan behaves in a very uniform manner in regard to the weather conditions, but we found in detail that the spatial variability of the rainfalls, for instance, is a lot more detailed. What we mean is that with the unique information of the conventional stations, it's not enough. We need more data to come up with more detailed surveys and studies. And this is the satellite images. We have assessed the type of sensors, many tests, and we have found out that there are no great differences amongst them. And the integral management of the basins to identify the best management practices for the best quality of water without compromising the natural resources. This was a map that was created to select the sites where this project would be implemented based on the main evaluation. And the main variable is the balance of water from the rainfalls in a basin. And then we analyze this water balance and the rational use on every side of the basin, and we use data, weather data, and we have identified that there are anomalies. These are data from different regions across the country. There are variabilities in regard to the data in the same station, and these are the rainfall anomalies. also gathered in this balance. This is a standardized index of rainfalls in a year or in a set of years, and this is an analysis of the severity of the drought into regions, into different seasons, upward in January and downward in September, and all of this to assess the water balance. This is to assess the weather variability, and in the lower parts of the basin, we need an irrigation, evapotranspiration, the requirement of water based on the objectives. What can we conclude? In the studies of a water balance, the rainfall variable is a variable, and the main entry, the information such as temperatures, velocity of the wind, solar radiation, play an important role. The availability of the information, weather information, is crucial. The spatial distribution of weather information allows us to regionalize the information and the recommendation. We need hydrometric and updated information to gauge the water balance algorithms. And with all this, the question would be, what's missing? And what does the Institute need to do? We need to improve the current infrastructure. Maybe in some cases there are some assessments that the sites where we have the station distribution is not ideal. We need to improve some sensors that are better gauged and based on the WMO characteristics. We need to enlarge the spatial coverage of the network, and we need climatic observations in the countries, that it's not so centralized. And we can see in detail, did you see this massive points? These are the distribution of the national networks and the use of forest lands in the higher lands. We don't have stations in the eastern part in the first map. In the green zones, these are the woods and rainforests that we don't have in Guerrero and Oaxaca. We don't have any meteorological stations. In the western Sierra Madre, no stations either. And when we looked at the map with a huge cloud of dots in the center, it would seem that all our needs are covered. But when we zoom in the green zones, which are the woods and the Popocatépetl and Michoacán, we have no automated stations. And we assessed these stations above 3,000 meters over the sea level. So we have only very few ones. We cannot assess the upper parts of the basins and the woods. We need to improve the communication systems, strategic projects, early warning systems, disaster evaluation, production potentials in regard to other institutions, participate in group work such as a Mexican norm that is being created for weather stations to harmonize the implementations and sites and metadata systems, communication systems, to join the national monitoring network that was created as of the Act on Climate Change, and we have been included to participate in the creation of a national network for environmental observatories from CONACYT and RETAC, and to come up with projects that are multidisciplinary in all levels. So a lot ahead, a lot to do ahead. We have done a lot, but this institute needs to still do a lot to fulfill the expectations we heard in the previous conference. Thank you very much.